to malls that are being built, like the new Soler in Quezon City, and many other offices, and we try to observe, no, and try to see which hazards are present and how we can improve these hazards. So actually, occupational health is promulgated by law. In the US, it's under the Occupational Safety and Health Act of 1970. It is a law that provides all employees with a safe working environment. So this includes you guys, your laboratory personnel, medical technologists, they are included in this law. And in the Philippines, we also have RA 110581, which is an act strengthening compliance with occupational safety and health standards and providing penalties for violations of 2018. So this law actually makes sure that an occupational safety and health administration is created. So RA, so let me just go back to that. RA 110581 creates your OSHA, or Occupational Safety and Health Administration. So what does OSHA do? OSHA is a government agency that creates the guidelines and protocols to ensure occupational safety. So in the different natures of job, we do have protocols and guidelines. Okay, so whether it be in manufacturing, construction, transportation, hotel, restaurant, etc. And even those that are not included here, they are all under OSHA. So OSHA creates guidelines, protocols to ensure that everyone is healthy. Now let's talk about the different hazards that are present in any workplace. So when we say hazard, again, this can be materials, no, present in the workplace. It can be equipment, machines, environment that can lead to unwanted effects such as injury, damage, death, and even loss. There are different types of health hazard. First is physical hazard. When we say physical hazard, this is the physical environment condition of the workplace. So the temperature, this can even be the location, this can even be the structure, no, of the workplace. We can also have your biological hazards, which includes, of course, the microorganisms that may be transmitted to the workers and may affect their health. So this includes us, no, doctors, medical technologists, nurses, since we work in healthcare. Also, medtechs are very much prone to chemical hazards. These are substances which are used as raw materials, even intermediate products, or even finished products and waste products, and even ergonomic stressors, which may result in the workers' discomfort in relation to their job and allows them or disallows them to reach optimum efficiency and productivity. So we will discuss all this one by one. So in any job that you will take and in any material that you use in your job, this should be labeled with a hazardous materials diamond, okay, or an NFPA. NFPA stands for National Fire Protection Association. Okay, National Fire Protection Association. So the diamond here is divided into four color-coded squares. And each diamond conveys information about this material. No? It conveys information about the hazard of this material. The top square is red and it describes flammability. The left square is blue and it describes health hazard. The rightmost is yellow and it describes reactivity. Reactivity also means radiation. Okay? And the bottom square is white and it's for special hazards. Now, each square, no, is also given a score or a number. So this number represents the type of health hazard. So let's say we're talking about the blue one first. So let's say you got a delivery of a new chemical, the chemical will get or will be labeled with a NFPA diamond. So when you were reading the diamond, you saw that this is the label, no? Flammability 3, health 1, instability 2, and special hazard. No, wala nakalagay. There's no um, number and no special icon here. So if it gets a label of 1 for health, it means that the material may cause irritation and minimal injury. It is number 3 for flammability, which means the ignition may occur. Okay? Instability, score of 2, which means it is unstable. So in every chemical, they would already inform the workers what type of hazard they are dealing with. Okay? Yeah. So let's talk about chemical hazards, since as medtechs, this is one of your most common hazards present. Again, chemicals are raw materials, intermediate products, finished products, or waste products that may cause injury to a person once exposed. So, for every chemical that we use in the workplace, we have to study first their physico-chemical properties. And then we study if ever a person ingests, eats, drinks, touches, smells the chemical, what happens to a person? We have to study that. What organ will be affected? What will be the biologic effects of these chemicals? Afterwards, we study the toxic substances. No, is it poisonous? What chemicals will really be a health problem? So what will cause irritation, sensitization, and carcinogenicity? We also study yung kanilang flammability, corrosion, explosibility, no? And we label them with the following stickers. So we put these stickers onto the chemicals that we use so that even if we don't read it, we will know or we will already be informed what type of chemical we are working with. So commonly these chemicals are used in the fields of agriculture, transportation, petroleum, electronics, health, and laboratory. So aside from getting a sticker, all chemicals that we use in the laboratory must also be provided with an MSDS. Okay, guys? The MSDS or Material Safety Data Sheet is a document, right? It's a document, a major source of information about the properties of the chemical. Now, who gives us the MSDS? Our employers are responsible for giving us the MSDS. Okay? Upon employment, they should give you the MSDS. So as you can see here, the MSDS, this is a real MSDS, guys. Ha? So we have here the name of the chemical. We also have its use, identified use as a laboratory reagent, who supplied this. If ever we get a problem, who do we call? And other information such as first aid procedures. If ever there is a problem, how do we do first aid? Firefighting procedures, handling and storage, exposure controls, even disposal, transport, etc. So all of this information should be in the MSDS. So if ever you will be working as medtechs and they won't give you the MSDS, then there is a problem. Okay, that will be a potential problem. Next, we have compressed gas hazards. So these are gases that we use in jobs in our works. And one example for that in medical technologists is liquid nitrogen. So yes, liquid nitrogen is not only used for cooking, diba? Usually we use that for freezing. But even in the lab, we use um, liquid nitrogen, especially in if you want to freeze some tissues. Okay? So compressed gas hazards are very dangerous because They can cause fire, explosion, asphyxiation, even tissue damage once we touch those gases. So next we have radioactive hazards. So when we say radioactive, they are unstable. Doc, what do we mean if they are unstable? It means that if we expose ourselves to unstable atoms or radioactive compounds, it will be capable of releasing sufficient energy to affect the atoms in our cells. And if our cells will be affected, it will lead to damage to our genetic material, to our DNA. And if there will be problems with our DNA, it can lead to diseases in us, or if not in us, to our children once we have children. Okay? So there are two types of radioactive compounds, ionizing and non-ionizing. So not ionizing is the one that is a little scary. So that includes your alpha, beta, neutron particles, also your gamma rays, and even X-rays. Okay? So X-rays pala, no, can be dangerous. Not when you get your X-ray of the chest or of your bones, because that's only one time, and usually we only get an X-ray at least once a year. But let's say you're working as a rad tech, di ba? A rad tech is exposed to X-rays every day, multiple X-rays in a day. So that will become a problem. All right? So radiation can be a problem for those who will get repeated exposure to radioactive compounds. Now we also have non-ionizing radiation. This includes your low energy compounds such as radio waves, microwaves, and visible light. So here is a table of your non-ionizing radiation. Can you take a screenshot of this? I will be asking this in your exam. Next, we have fire hazards. So fire hazards are anything which may cause fire or anything which may inhibit fire safe behavior. So before a fire can develop, there are three basic elements or what we call the fire triangle. This includes fuel, heat or ignition, and oxygen. Kindly remember those three elements of a fire: fuel, heat or ignition, and oxygen. But nowadays, they consider a fourth element, and that is the chain of reaction, which means, yes, there can be fuel, heat, and even oxygen all at the same place, but without a chain of reaction, a fire will not happen. And that's true, right? That's true. So, in terms of the materials in the workplaces, they have to be labeled with the fire hazard. Is it A, B, C, D, or K? So when we say A, these are ordinary combustibles such as wood, paper, cloth. B are flammable liquids, grease, oil, paint. C is for live electrical equipments, so wirings, motors, sockets, electrical panels. D are for combustible metals, and K for flammable cooking equipment such as oils. All right? So, let's say a fire happens in your workplace. God forbid naman. No? So, what should you do? Remember to race. The acronym is RACE. First to rescue your workmates. That's the first thing you should do in case of a fire. You do not get your phone and record what's happening and you do a Facebook Live. No, that's not the thing to do. First is to rescue the people inside the workplace or inside their houses. A is to alarm everybody else. Alarm the police, alarm the fire station, alarm the other people in the other floors or in the buildings right beside yours. C is the only time once you've done rescuing and alarming, that's a time you will try to contain the fire. E is extinguish. So basically, you should know where the fire alarm is, where the fire extinguishers are, where the fire exits are. Now, let's say you are already containing the fire and extinguishing the fire. How do you use a fire extinguisher? Just remember the acronym PASS. First, pull the pin, the safety pin of the fire extinguisher. Next, aim low at the base of the flames. Squeeze the handle and then sweep side to side. That is how you use a fire extinguisher. And then there are several fire extinguishers in the market. We have foam, we have water, we have wet chemical, we have carbon dioxide, we have dry powder, and L2M28 powder. So you can see here in this diagram what type of fire a certain type of extinguisher can um, can address. So foam extinguishers can be used for ordinary combustibles and flammable liquids. Water is only used for ordinary combustibles. Dry powder can be used for most except for metals. The only one that can be used for combustible metals is your L2 and M28 powder. So kindly take a screenshot of this as well. I will also ask this in your semis and in your quiz. We also have electrical hazards. So this is anything that can cause electrocution, electric shock, electric burn, explosions, and fires. So how do we get electrical hazards? When we get in contact with energized sources. When we get in contact with power lines, di ba? Hinawakan mo yung cord. When you use extension cords and flexible cords, such as this. So when you look at this extension cord, may extension cord na, pinsaksakan pa na extension cord ulit. When you have wires that are already chipped off, no? And when you still use these kinds of sockets, that is already an electrical hazard. What should you do? First, you have to unplug equipment that are not in use. Make sure that those equipments, yung sockets, extension cords are used in a dry area. You should also have explosion-proof equipment if ever you're working with high voltage. No? So you should know if an equipment is high voltage. You should also use grounded equipment. When we say grounded, those that prevent um, electrical currents from going out, such as a three-pronged plug. And we should always check for frayed electrical cords and be able to report. Let's say you inserted a socket, a plug inside the socket, and then you saw a spark or a tingle, you should report that. And do not work on live electrical equipment. We also have mechanical hazards, and when we say mechanical hazards, this is actually anything that moves and can cause injury. So, di ba, in factories, especially mga automated factories, you already have those moving equipment. So, let's say you got your hand caught in that moving equipment, then that's gonna be a problem. Di ba? So, this can include tools, machines, and vehicles that may cause injury. So, usually it can also include surfaces, um, edges, that has the potential to crush, burn, cut, shear, stab, strike, or wound workers. So, if ever there are mechanical hazards, you would also see these signages, no, labeled in those machines and equipments. So, pwedeng moving parts, dangerous surfaces, mobile work equipment, uncontrolled moving parts, slippery surfaces, and even a crash. And lastly, we have ergonomic hazards. So when we say ergonomics, it is the fit of the worker to their job. Okay, basically routine. Now we are talking about routine and comfort in ergonomic hazards. So this is associated to human actions that you do in the nature of your job. So are you lifting? Are you pushing? Are you pulling? What's your posture in your job? So if the nature of your job is not fit for, let's say, your body type, your height, your posture, then that's going to cause injuries as well. And it is more common for those that do repetitive manual tasks. Ayan. An example. Let's say you're working a Monday to Saturday job and you are just seated on a chair in front of your computer. You're working for prolonged hours, of course. The, your eyes will eventually get damaged. You'll get neck pain, back pain, knee pain, ankle pain because of the posture, especially if you have prolonged sitting, no? Yan. So, ito yung mga ergonomic hazards natin. Now, in the laboratory, there are also rules that were implemented to ensure that you guys are safe. So, in the US, it started in May 1990, also known as laboratory standard. Okay, so it provided laboratories with guidelines on how to handle your chemicals in the lab. Also, we have in the laboratory what we call hazard communication standard. So these are rules that should be communicated to all employees and employers. So basically, all chemicals should be properly labeled and all workers should be given an MSDS. So now that we know what the hazards are, do we just leave them at that? Of course not. If ever we identify a hazard, we should do something to control the hazard and to prevent the hazard from developing or causing a disease. So now we have the 5 ways on how we can control and prevent occupational health diseases. So as you can see, it comes in the form of an inverted triangle or pyramid. This means that the most important is the one on top, elimination, followed by substitution, engineering control, administrative control, and then PPE. So basically, when we have a hazard in our workplaces, no, the first thing that we should do or the first strategy to address the problem is try to eliminate the hazard. Okay? That's the first thing we should do. Now, let's say that you cannot eliminate the hazard. No? You cannot eliminate the hazard. Then, that's the time you will go to substituting the hazard. If you cannot eliminate it, then maybe you can replace it. No? If still substitution will not be enough, then maybe we can do engineering controls. If still the problem will not be solved by engineering controls, then maybe we can do administrative controls. If it still will not work, then let's do PPE. So basically, it's a hierarchy. First, you try elimination. If it will not work, then you move on downwards. Okay? So let's say elimination. When we say elimination, we separate the hazard from the worker. How? By increasing the distance between the two or increasing the time of contact or decreasing rather the time of contact between the hazard and the man. So let me give an example. A number of workers have been found to have hearing loss due to exposure to unhealthy sound frequencies. So this is common especially for those working in construction, diba? I'm sure you've experienced the roads, yung mga kalsada, no? Kapag kino-construct sila, it causes a lot of noise. So, for us, for the residents, we would only experience that at least maybe once in a few years. But for, let's say, construction workers, and that's the nature of their job, no? Every day of their life, they have to hear that noise of the jackhammer. So, eventually, it will cause hearing loss for them. So, how do we eliminate the problem? We can isolate the area where the noise is coming from. So you are now eliminating the source of noise, no? And we can even use soundproof covers. So you eliminate the time of exposure. Elimination can also mean completely removing the hazard. Okay? So, example of this, during the summer, construction workers were complaining of severe headache, burning eye sensation, difficulty of breathing, and dehydration. So these are signs of heat stroke. So what can we do to eliminate this? We cannot eliminate the sun. We cannot eliminate the weather. No? So how do we limit their exposure to these factors, to heat? Eliminate the working hours during noontime and transfer their jobs to night shift. Okay? So that's how we eliminate exposure. Hopefully you're getting the drift. And in the exam, guys, it will be like this. You will be given a situation and you will come up with your control. For substitution, so substitution is the use of a different material, product, or activity. It can be the use of a different process, method, or machine instead of the hazardous ones. Basically, the keyword here is replacement. When you are replacing it with another material or activity. So let's go to the example. Workers have complained of burning sensation to their eyes and nose with difficulty of breathing when they use a certain brand of paint. So how do we substitute this? Use a different brand of paint. Diba? So yan. How about engineering controls? Engineering controls means to require physical changes to the workplace environment. So now when you will build, no, you will build into the design of the plant meaning the workplace, if you will build into an equipment or a process to minimize the hazard, that is an engineering control. So we have an example. Workers have been falling sick due to respiratory illness because in their workplace they are being exposed to smoke or local exhaust. So how do we address this? By engineering. So they built a ventilation system to remove the smoke so that workers will not inhale the smoke anymore. Okay? Next, administrative controls. It is changing policies, rules and regulation, safe work practices in the workplace. So policies may include your break time, rotation, schedules, job orientation, and even choosing the proper workers for the right kind of job, and requiring health examinations for workers. So example, workers have been found to have worsening eye conditions due to prolonged working hours during the night. So of course, we start first again with engineering, di ba? Elimination. So maybe we cannot eliminate nighttime. Andiyan talaga ang gabi, di ba? It always comes. So we cannot eliminate that. So what can we do? Can we eliminate the job requiring them to use their eyes? Of course not. So maybe we can substitute. Try to use a different light, di ba? So replace the light bulbs or yeah, pwede natin gawin yon. But let's say, still, they're complaining of worsening eye conditions. Hindi pa rin gumana yung engineering controls mo, yung substitution mo. Then, we do administrative controls. Change the schedule of workers. The night shift, make them morning shift. The morning shift, make them night shift. And then they will change again, let's say after 2 months. Okay? Yan. And lastly, it's my last slide, PPE or personal protective equipment. This is the lowest control. You saw naman in the inverted pyramid. This means that we only use PPE when all other controls are ineffective or it is our last resort. So PPEs can be head to foot or it can also be localized. So for construction, this is their PPE. But for us working in the health sector, this is our PPE. Okay? So that's my last slide. Thank you guys. Let me just take a screenshot of our attendance this afternoon.